Alright, this is the final video on the review that I will be doing, and then you will have your homework assigned to you. So I'm going to start with, on the second page, number 7. So we're almost done with these right here. So 7 is kind of like number 6, which I did last time. So you have 4x, but you have it inside of the ln. So it's not just ln of 4, it's actually ln of 4x. So the only way to get rid of the ln you've learned is to take the e of both sides, so take the e of this side, which makes the 3 become an exponent. So this cancels. So actually what we have is 4x equals e to the third power, okay? And then you just solve for x, e to the third divided by 4. So you should get x equals, if you plug that in your calculator correctly, you should get, let me look, 5.0214. 5.0214, and a reminder, you are taking it to the 4th decimal place, so just remember to show all that. Okay, and then the next one we're going to do is number 10. Number 10 is down here, so you're going to use the change of base formula to express each logarithm in terms of common logs. So then approximate the value to 4 decimal places. So basically, you cannot plug log base 3 into your calculator, or into most calculators. Log base 3 of 7. You want that base to be 10 because the log button in a calculator is base 10. So the way to convert this, which I told you, is log base 10 of 7 over log base 10 of 3. So the number out here over the base, and you're good. So you should plug that into your calculator, and you should get 1.7712. That is your answer to the 4th decimal place. So make sure to know how to do that for 11 and 12 as well. Okay, we are going to skip to 13. 13. A radioactive substance has a half-life of 32 years. Find the constant K in the decay formula for the substance. Okay, you need to go find all of those formulas. There was 4 that Mrs. Worker taught you. There was 2 increasing and 2 decreasing equations, so make sure to go find those. In this case, we see the word decay, so we know it's going to be one of the 2 decreasing, and since there's no percentage given or no percentage asked for, it's actually half-life, we know we are going to use, let's see, there's not a lot of room. I'm going to go over here. We know we are going to use the formula that says A equals, I think it's y equals a times e to the kt, and since it is a decay, it's going to be negative kt. So you are going to use the decay formula for that one, and that's because there's no percentage of decay or increase, which means you're not using the equation with r. Okay, so the only number that is given here is this 32 years. A radioactive substance and this half-life is kind of a number. So that's all that's given, and you're finding K. So the only thing you shouldn't know is K. So we need to write this out. Y equals something, A equals something, E is a number, K, we don't know K, that's what we're solving for, and T is something. Well, we know T is that 32 years, and we need to make Y and A in the same unit, so actually Y is our final number, and A is our original amount. So we're going to leave A as A, and our final amount is half-life, okay, half-life, so we need our final amount to be half of our original. That is why we name it 0.5a. Okay, so we're going to rewrite this whole equation as 0.5a equals a times e to the negative k, we don't know k, and we know 32. Actually, I'm going to rewrite that in the form of putting the 32 first, negative 32k, okay, because that's how we know how to do these. And then actually you can just cancel out the a. If you divide by a on both sides, okay, the a actually goes away on both sides, and that's really good because now the only unknown that we have is k, which is what we're solving for, e to the negative 32k. And just like in the old problems, the other problem I did, you have a k up in the exponent and you need to get it down to earth, so we're going to take the ln of both sides, and we have ln of 0.5. This goes away. What we have is negative negative 32k, divide by that negative 32, and we should get our answer. And I know I went through that pretty fast, but you can slow me down and go find the answer. Go try it again yourself. But the answer should be 0.02. Okay, that is the answer. You can go check the work yourself. 0.02. Yep. Okay, now 15 is a little bit different. This has a lot more numbers in it, so we need to figure out what it's asking. There are 850 students at the high school, so that is going to be an initial number, probably, which represents full capacity. The town plans to add an addition to house 400 more students. Okay, so that probably adds to the final number. If the school population grows at 7.8%, that tells me I'm going to use the R equation. In how many years will the new addition be full? So I'm going to just go write some of my thoughts over here. So I know that I'm going to use the R equation, and I know I'm going to use the positive form of it. So I know I'm going to use A equals, or no, is it Y? Y equals A times 1 plus R to the T. I put the plus sign because this is an increase, okay? And that's confusing because there's no bigger, the 850 is the biggest number, but it's also the initial, so we need to figure this out. So we need to write out our Y equals, our A equals, R and T. And the one that they're asking for is, in how many years will the new addition be full? So that means they're asking for time. How many years? Okay, and then they gave us a percentage, 7.8%. That is, you need to remember to move that decimal place over 2 decimals. Okay, so our answer here is actually is actually 0.078, not 0.78. That's 78%. 0.078 is 7.8% increase. Okay, a 78% increase is very big. 7.8 increase is not that big. Okay, A is the initial amount, so I know that we started with 850 students. And the final amount, it's 400 students more. Okay, it's 400 students more than it was before. So the final amount is actually going to be 850 plus 400. So the answer here is actually 1250. It's not the 400, so it's a new number that wasn't there. Okay, so I'm going to go plug in what I know. I know 1250 equals 851 plus 0.078 to the T. Okay, I'm going to divide out this 850 right now so it goes away. Divide it over here. I'm going to get a decimal. That decimal is 1.4706. 1.4706. Okay, and I'm going to get 1.078 to the T over here. And the unknown is in the exponent. We know what we need to do when it's in the exponent. We need to take the log of both sides. Okay, so our new answer is going to be log of 1.4706 equals, and that becomes log of 1.078 T. That T can come to the front, so log of 1.4706 equals T log of 1.078. Okay, now we have our T almost by itself. It's in the front, we just divide out this log and then it's all by itself. We had to get it in front because we couldn't get everything else gone if we didn't do that. So we have T equals, if you plug this correctly into your calculator, you should get 5 years. You should get 5, and it's in terms of years. So basically in 5 years, the